Have you ever wondered why a ball rolls down a hill or why a car slows down when you take your foot off the gas? Newton's laws provide the answers to these questions and many others about how things move in our everyday lives. Newton's laws of motion, formulated by Sir Isaac Newton in the 17th century, are fundamental principles that describe how objects move and interact with each other. These laws serve as the basis for classical mechanics, the branch of physics that deals with the motion of objects and the forces acting upon them. Understanding these laws of physics enables us to explain and predict the behavior of objects in a wide range of scenarios, from the motion of planets in space to the behavior of atoms in a chemical reaction. Mastery of these laws is essential for anyone studying physics or engineering, as they provide a fundamental understanding of the physical world. Newton's laws are like the instruction manual for how objects move and interact with each other. They explain why things move the way they do and why they stop or change direction. These laws give us a set of rules for understanding how forces affect motion. They help us break down complex movements into simpler parts so we can understand them better. By applying Newton's laws, scientists and engineers can analyze the forces acting on an object and predict its motion with precision. This ability is crucial for designing and building everything from bridges and buildings to spacecraft and satellites. Classical mechanics, also known as Newtonian mechanics, is the branch of physics that deals with the motion of macroscopic objects. Newton's laws provide the foundation for classical mechanics, guiding our understanding of how objects move and interact under the influence of forces. Engineers and designers use Newton's laws to design and optimize structures, vehicles, and machines. Whether designing a new airplane or improving the performance of a car, knowledge of Newton's laws is essential for ensuring the safety, efficiency, and functionality of engineering projects. Many everyday phenomena can be explained by Newton's laws of motion. For example, the motion of a car on a highway, the flight of a baseball through the air, and the operation of a roller coaster all follow the principles outlined by Newton's laws. By studying these laws, scientists gain insights into the fundamental principles that govern the behavior of the universe. These laws describe how objects interact with each other through the force of gravity and other fundamental forces. They also provide a systematic framework for analyzing the motion of objects and the forces acting upon them. By applying these laws, scientists and engineers can break down complex systems into simpler components and analyze their behavior. Studying Newton's laws requires students to develop critical thinking skills and apply mathematical concepts to real-world problems. By mastering these laws, students develop problem-solving skills that are valuable in a wide range of academic and professional fields. They develop the foundation for many other concepts in physics, including energy, momentum, and fluid dynamics. By understanding these laws, students can build upon their knowledge and explore more advanced topics in physics. Whether working in engineering, medicine, finance, or any other field, knowledge of physics can be valuable for making informed decisions. Understanding Newton's laws allows individuals to analyze data, evaluate options, and make predictions based on scientific principles. Newton's laws have inspired generations of scientists and engineers to explore the mysteries of the universe and develop new technologies that improve our lives. From space exploration to medical imaging, the principles outlined by Newton's laws continue to shape our understanding of the world around us. By studying these laws, students gain an appreciation for the interconnectedness of physical phenomena and the underlying principles that govern them. This interconnectedness underscores the unity of the natural world and the importance of interdisciplinary thinking in science. Newton's laws provide a common framework for describing and analyzing motion that transcends cultural and linguistic barriers. Whether communicating with scientists in other countries or collaborating with colleagues from different backgrounds, knowledge of Newton's laws provides a common language for discussing and understanding the behavior of objects in motion. By mastering them, students gain the skills and knowledge needed to engage with scientific research and contribute to advancements in physics and related fields. Whether pursuing a career in academia, industry, or government, a deep understanding of Newton's laws can open doors to exciting opportunities for scientific discovery and innovation. By learning about Newton's laws and applying them to real-world problems, you can become a part of the scientific community and help make new discoveries that improve our lives and our understanding of the world around us.